Okay, this lesson we're going to do the quotient rule. All right. Again, we have done the quotient rule in class, so I'm just going to use the this opportunity to go through some exercise questions, like in terms of quotient rule. All right. So for the quotient rule, that firstly you need to understand there's a formula y equals to u over v. The formula tells you that the derivative y dash is equal to, you square the denominator first, all right? So no matter what denominator is equal to, square it, all right? And then once you finish that, you find the derivative of the top numerator first, times by the denominator, and then switch them around. You find the derivative of the denominator, and then you times by the numerator. So that's the formula. I use the formula to do the question, but I never really write down the formula. I know sometimes the student, they like to write down the formula before they find out u dash v, v dash u. But I just remember the process. The process will be just, square the denominator, differentiate the top first. This time, the order is important, because that's that's a negative in between of these two. So you can't just switch them around. Not like the product rule, you can switch them around and the order is not important. You can differentiate the first function first or the second function first. It doesn't really matter. Okay, so I'm just going to use a very simple example from the textbook to show you the quotient rule. All right, so probably we're going to just do this question here. That is exercise 9i, question 2. H. The question asks you to differentiate it and express your answer in a fully factorized form and state any values of x which the tangent is horizontal. All right. Question 2. H. So y is equal to x squared minus 9 over x squared minus 4. All right, so the first step here, we need to differentiate it. So dy over dx. We are going to apply the quotient rule to do this question. So the first step is you square the denominator. Now, usually when you square the denominator, there's no need to expand, okay? So try not to expand it. Just leave the answer like this. Hopefully, after you finish your derivative and numerator, maybe after, final factorize the form, you can sort of cancel the terms, all right? So leave the answer in terms of the square, it's a whole bracket. Now, the next step is you need to find the derivative of the top first, which is 2x. Then you times by the denominator. Okay, now remember it's minus. Then you find the derivative of the denominator, which is equal to 2x again. And then you times by the top. So if you follow this pattern here, you differentiate the top first, times by the bottom, then you differentiate the bottom, times by the top. It's pretty, straightforward. Okay, now we need to factorize. So take the 2x outside. That becomes x squared minus 4 minus x squared plus 9. So it's a pretty easy question. So that becomes x squared minus 4 square. All right, at the end, after you simplify it, that gives you 2x times by 5 over x squared minus 4 square. All right, so once we finish this, the next question asks you to find any x values where the tangent is horizontal. So if we just let dy over dx equals to 0, where the tangent is horizontal, that gives us 10x over x squared minus 4 square equals to 0. Okay, all right, so that means we have 10x is equal to 0, x is equal to 0. So when x is equal to 0, there is a horizontal tangent at that point. Okay, so that's how we do question 2H. Pretty easy. This is the very beginning sort of question here, so shouldn't have any problem. All right, now I'd like to do another one this time. So I'd like to do question 8. Okay, question 8. Question 8 is quite interesting, all right? The question 8 asks you to differentiate this one and use the quotient rule. In the bracket, they say it's better method. Then use the product rule with the same function to do this question here. So we're going to use both product and quotient rule for this question here, and you can decide which one is easier for you to do and what's the reason behind. Personally, I prefer that, if it's a product rule question, use the product rule. If it's a quotient rule question, just use the quotient rule to do the question, instead of instead of just do it, if it's a fraction, then you start to use the product rule. Okay. Right, so we're going to use the quotient rule first. Okay, right, so dy over dx is equal to, all right, as usual, okay, just going to draw a long line for the fraction, and then we need to square the denominator. Now we need to find the derivative of the numerator, which is equal to 2, we're times by the denominator, then minus the derivative of the denominator, which is minus 2, okay, be very careful, all right, that's minus 2, and e times by the top. Okay, once we finish that, we expand and simplify the numerator, so that gives us 10 minus 4x, that becomes a plus, so plus 10, and then plus 4x. All right, so at the end, the answer is pretty straightforward. It is 20 over 5 minus 2x everything squared. All right, so this is just using the quotient rule to do the question here. All right, so some students prefer to use the product rule, all right, just because the quotient rule, sometimes it's a bit hard to sort of memorize which one you need to differentiate first. So sometimes the student prefer, hey, I would like to use the product rule instead of quotient rule. All right, so if you want to use the product rule, the first step is you need to make sure that is in product, right? So instead of 5 plus 2x over 5 minus 2x, the first step you need to do is change that into 5 plus 2x multiplied by 5 minus 2x to the power of negative 1. All right, and you start to apply the product rule, which means you're going to differentiate that one times by the original function here. Then you differentiate this one times by the original function there, and then you plus them together. All right, let's start. So dy over dx is equal to, now if you differentiate that part, it gives you 2. Then you times by the original function for the second one. Then you plus. Now you differentiate that one. That's not that easy to differentiate because you've got like a minus 1 here. So you need to move. You need to use the chain rule. So minus 1 becomes minus 2. And then you have to times by another minus 2, which is just a chain rule. Then you still have to times by 5 plus 2x, which is the original of the first equation function. So as you can see, it takes a long time to differentiate it, okay? Now, still haven't finished. We need to change that into a fraction. That is the first term. That becomes the second term here. All right, and then you still need to combine them together, which now, as you can see, this denominator and that denominator here is almost identical apart from there's a square, so I need to times the numerator here by the same term. Now becomes a square, all right, and then you can combine them. Now, if you pay attention to what we did before, this expression is exactly equal to the expression here. So I'm going to show you here. It's exactly equal to the expression here. Okay, so have a look at this expression there. And comparing to that, are they the same? They are the same expression. So what does that mean? You've done so much steps here. All of those steps here, basically at the end, you still haven't got an answer. You still get to just the first step of the quotient rule. So therefore, the product rule is not a good way to do this question because you want to avoid using the quotient rule. Okay, it's not ideal. Okay, don't use it unless the questions give you a question and they ask you specifically, they tell you to use the product rule. Otherwise, please don't use it. It's not efficient. Okay, all right. So it's a good question 8, and it tells you that it's sort of using one example to prove that it's not efficient using the product rule to do the quotient rule question. Okay, all right, so let's find another question. I'll do a question where, yeah, I'll do this one. Yeah, that's a good one. Okay. I guess maybe we can do a question 10b, okay? What happens if we have, a square root on the denominator, 10b? So we've got y equals to x minus 3, or actually there's no y, so we're going to differentiate d over dx, x minus 3, square root of x plus 1. Let's just have a look at what the question asks you to do. Alright, differentiate stating any zeros of the derivative. Alright, good. Stating any zeros of the derivative, which means we just let the derivative equal to 0 and, find the value of x. Alright, typically this is just a quotient rule question, so as usual, a long line. Now I need to square the denominator. In this case, okay, in this case, it's just equal to x plus 1. Okay, that's pretty easy. All right, because of the square root, and if you square it, it becomes, x plus 1. All right, now you need to differentiate the top, the numerator. The derivative of the numerator here is just equals to 1. All right, and that means you times by the denominator, which is x plus 1, the square root, minus. Now you need to differentiate the derivative. You need to differentiate the denominator. This becomes a bit tricky. All right, it is a square root here. So what you can do is on a square piece of paper, write down this is to the power of half, and then you differentiate. All right, and once you finish that, you times by the top, which is the numerator. Okay, so once you have finished that, then the next step is you need to simplify. Okay, so how do I simplify this? There's a half here, there's another negative half there. So the first step you can do is, you can do it as a separate steps. I want to times everything by 2 first. So that would be a 2. That would be just x plus 1 to the power of negative half, x minus 3. So what I did here is I times both the top and the bottom by 2, just because I want to get rid of the half here. So you need to times by 2 here. You also need to have a 2 in front of the denominator, x plus 1. Okay, now once this is done, all right, the next step you can do is you want to sort of get rid of that one here. So there's a couple of ways you can do it. You can factorize it, taking a smaller factor, or you can just multiply both the top and bottom by x plus 1 to the power of positive half. All right, if you've done that, okay, then these two terms, when they times together, remember this is also a square root, which the power is equal to half, and if you use the index law, that just becomes 2x plus 1 to the power of 1. The term here disappeared, so minus x minus 3 over 2x plus 1 to the power of 3 on 2. I prefer to write it in terms of a fractional power instead of a square root. Of course, feel free to write it into square root if you want to, but that's, that's about it. All right, next we just need to expand the numerator, and we simplify it. Okay. All right, so that's it. So, at the end, we just need to find the value of x, for which the derivative is equal to 0. So, at the end, x plus 5 is equal to 0, x is equal to minus 5. Okay, that's it for question 10b. It's slightly tricky because the denominator is equal to the square root of x plus 1. So just be very careful about how you're going to differentiate the square roots, change that, and make sure you change that into the fractional power before you do that. Apart from that, the rest of the work is pretty straightforward. Okay. Question 15 is interesting. This just says differentiate this function using the most appropriate method. Obviously, you need to decide which one is the best method for different questions. So it's not always about using the quotient rule to do the question. I can see some of the question requires you to use the product rule, others requires you to use the chain rule, and there's some question where it's a combination of a product and chain. Just be a bit careful about it. Yeah, that's all. Now you can try a few questions from this exercise. That shouldn't be very hard, to be honest. Okay, thanks for watching.